Okay, guys, good morning. Let's take a look at your quiz review questions. All right, you guys are going to have your quiz tomorrow, and your quiz will look something like this. So these are questions that'll help you prepare. Okay, so let's take a look at the solution to that first example. It says we want to find the area of the circle, where to go to the nearest tenth, and we're given information that the radius is equal to 3.1 meters. All right, so when we're finding area of the circle, we always start with the formula. All right, and we write the formula. Area is going to be equal to pi times the radius squared. It's always step one. Step two is our substitution step. So area is going to be equal to, well, we're told to use 3.14 for pi, so I'm going to replace pi with 3.14. Remember, 3.14 is an approximation for pi. Pi is the ratio of a circle's circumference to diameter. That ratio of any circle's circumference to diameter is always about 3.14, which means that in simple language, the distance around the circle is about 3 times the distance across the circle. All right, so we replace pi with our approximation for pi, 3.14. Our radius is going to be 3.4, right? But we have to square that radius. So your area is going to be equal to the following. Well, with your calculators, you want to do 3.4 squared. So with your calculators, you want to enter 3.4 times 3.4, and that's 11.56. So this is going to be 3.14 times the 11.56. All right, and we have to do that exponent before we do the multiplication. So just be careful with your order of operations. Then you multiply by 3.14, and we wind up with 36.2984. Area is going to be equal to 36.2984, and the units here would be square meters. Now, we compare our answer to our answer choices, and I see 36.2984. We have an answer choice of 36.3. So if we were rounding that answer to the tenths place, right, we'd look one place to the right of the tenths. That 9 tells me to round that 2 up to a 3. And that's where we get our answer to the nearest tenth, because we are asked to go to the nearest tenth here, of 36.3 square meters. Right? So that's what problem number 1 would look like. Question 2, similar type of question, but instead of being given the radius of the circle, we're given the diameter of the circle. And the diameter is the distance across the circle with endpoints on the circle. Okay? We're going to start the problem the same way by writing our formula. So area is going to be equal to pi times the radius squared. But there is no formula for finding the area of a circle if we're given the diameter. So we have to find the radius of this circle in order to find the area. So to find the radius, we have to take that diameter and we have to divide it by 2. So with your calculators, you take 11.6 and you divide that by 2, and that winds up being 5.8. All right, and our units are meters. So the radius here is going to be 5.8 meters, and that's what we're going to have to use in our calculations. So area is going to be equal to, well, for pi, we're told to use 3.14, so we're going to continue to use 3.14 for pi. So area is going to be equal to the 3.14, and our radius is going to be the 5.8, but we're going to have to square that radius. So with your calculators, you're going to do 5.8 times 5.8, right? Because that's what 5.8 squared is. Squaring is when we multiply a number by itself. So 5.8 times 5.8, we wind up with 33.64. So this is going to be 3.14 times the 33.64, and then we find that product. So our area is going to be equal to, let's see, calculator, 105.62. We have 105.6296, and those are square meters. But once again, we're asked to round to the nearest tenth. Here's our digit in the tenths place, the 6. We look one place to the right. I see a number, the number 2. A 2 is less than 4, so, or less than 5 actually, so we have to leave that 6 itself. We don't change it. So our answer to the nearest tenth is going to be 105.6 square meters, and that's going to be answer A. All right, so I should have written my letter A because I like to do that, and I didn't do that for this problem. All right, so let me go back to problem 1, circle it, and we had answer B for problem number 1. Okay, let's look at question 3. Question 3 says, Maria is planning on making a circular garden. If the diameter of the garden is 42 yards, what's the circumference? Well, we have to start with our formula for circumference. Circumference is going to be equal to pi times the diameter. All right, and let's see, circumference is going to be equal to, we're told to use 22 over 7 for pi, and let's see, and the diameter is 42. All right, we're going to divide out 7 and 42 by 7, so 7 divided by 7 is 1, 42 divided by 7 is 6, and then we multiply numerator times numerator, denominator times denominator. 22 times 6 is what? 120 and 12, 132. 132. And those are yards. Right? So we get, for problem 3, answer A. Question 4, we want to find the area of the figure. We're told to use 3.14 for pi. We want to round our answer to the nearest tenth. Well, this is what's called a composite figure. A composite figure is a figure made up of more than one shape. Okay? Well, what do I mean? Well, we have this first shape here. Right? I'm going to call this figure 1. Right? And figure 1 is a rectangle. The second shape we have, I'll call this figure 2. Figure 2 is a semicircle. To find the area of a composite figure, we have to find the area of each figure, and then we add those areas together to find the area of the composite figure. So let's start with area 1. Area 1 is a rectangle, so the formula that we use to find the area of a rectangle is length times width. Well, we're given the length is 30, we're given the width is 15, so we're going to have 30 times 15. So area 1, when we multiply 30 times 15, 15 times 3 is 45 and a 0. So that's going to be 450, and those are square meters. And now we also have area 2, which is the semicircle. So I'll do that in red over here. Area 2, how do we find the area of a semicircle? Well, the area of an entire circle is pi times the radius squared, like we saw in some previous examples. But this is a semicircle, which is half of a circle, so we have to take the pi times r squared and divide it by 2, because it's a semicircle whose area is equal to half the area of a circle. So area 2 is going to be equal to, well, for pi we're told to use 3.14 as usual, so it's going to be 3.14. Our radius, well, what's the radius here? Let's see what we have for the radius. Well, the radius is the distance from the center to an endpoint on the circle. So we're looking at this purple distance here is our radius. Well, I'm given this distance is 15, so our radius is going to be half of this distance of 15, so our radius has to be 7.5, and those are going to be meters. So in my formula, we have to use the 7.5. We're going to have to square that, but then remember, we want to divide that by 2 because we're finding the area of a semicircle, which is half the area of a circle. Now, when you're doing this problem with your calculator, right, we have to use our order of operations. So this exponent has to be done first. So 7.5 squared is found by taking 7.5 and multiplying by 7.5. All right, so let's do that. 7.5 times 7.5. That's going to be 56.25. So we get 3.14 times the 56.25, but then we have to square it, okay? And then let's multiply that times 3.14, and then we said, oh, we have to divide by 2. So and then we divide that by 2, and we get an area 2. Area 2 should be 88.315. Those are also square meters. Well, now, remember, we're looking at the area of a composite figure, which is composed of the rectangle and the semicircle, so we have to find the total area. And we find the total area by adding area 1 plus area 2. So we're going to have 450 plus 88.315. All right, and let's do that. And we wind up with 538.3 if we're rounding to the nearest tenth, and those are square meters. All right, and I want to match that answer. It looks like that's going to be answer B. So for problem 4, we get answer B. All right, but look at the work that we had to do there. Right, a lot of good work. We're already organizing our information carefully. All right, and circle or box that answer. Okay, next example, example 5. Once again, we're being asked to find the area of a composite figure. And the area of the composite figure is made up of 2 separate figures here. So I want to find the area of figure 1. We'll call this rectangle figure 1. All right, and then we'll call this triangle figure 2. And to find the area of the composite figure, we're going to have to add those areas together. All right, so let's do area 1 first, which is a rectangle, so we're going to use length times width. Area 1 is going to be equal to, I see the 14 and I see 21. So that's going to be 14 times 21 for the length times width. So area 1 is going to be equal to, let's see, 14 times 21. It's going to be 294. And those are square centimeters for area 1. Area 2 is the triangle. For a triangle, we use the formula 1/2 base times height. So area 2 is going to be equal to 1/2. Well, we're given the base here of the triangle is 16. But what's the height of the triangle? All right, we're going to have to do a little investigating to find the height of the triangle. Well, here's the height of the triangle. Well, I'm told this distance here is 21, and I'm told this distance here is 12. So if this is 21 and this is 12, our height is the difference of 21 and 12, because 12 plus what is going to give us 21, right? So that's going to have to be what? 21 take away 12, right? 9 centimeters for our height. So the height we're going to have to use is 9. So with our calculator, we do 1/2 of 16 times 9. So area 2 is going to be equal to 1/2 of 16 is 8. 8 times 9 is 72. And those are square centimeters. And now when we're looking for the area of the composite figure, we simply need the total area. So the total area is going to be equal to area 1 plus area 2. So that's going to be the 294 plus the 72. 294 plus the 72, that's going to be equal to, let's see, 366. That's 366. Those are square centimeters, and it looks like that's going to be answer C for question number 5. All right. Question 6. You've seen this problem a lot, so you would expect to see it on your quiz. All right. We have to find the area of what? This entire composite figure. Now this composite figure is a little different. All right. First of all, it's made up of 2 semicircles, right? And I'm highlighting those semicircles in blue, right? the semicircles, when put together, make one whole circle. So we're going to call that area 1. Area 1 is simply the area of a circle. Area 2 is the area of this rectangle here. All right, and area 2, I'll highlight that here. So let's start with finding area 1. Area 1 is going to be equal to pi times the radius squared, because it's the area of two semicircles, and when we put the two semicircles together we get an entire circle, and the area of a circle is pi times the radius squared. So area 1 is going to be equal to 3.14 we'll use for pi. Now what's the radius of that circle? Well, the radius is the distance from here to here, right? If this is 18, means that the radius then would have to be 9. So the radius is going to be 9, and we're going to square it. So area 1 is going to be equal to 3.14 times 9 squared, which is 81. So area 1 is going to be equal to, let's do that, Claire, 81 times 3.14, wind up with 254.34, and those are square feet. Okay, well, let's find area 2. Area 2 is a rectangle. For a rectangle we use length times width. So area 2 is going to be equal to, we have 4.5 times 18. So length we're going to replace with the 4.5 feet. The width is going to be 18. So area 2 is going to be equal to, let's do 18 times 4.5. We wind up with 81. All right, and those are square feet. Well, we need the total area. All right, so the total area is going to be equal to area 1, right, plus area 2. So area 1 plus area 2, right, let's find that. That's going to be 254.34 plus the 81. Right, so we do 254.34 plus 81. Let's do that. 254.34 plus 81. We wind up with 335. So our area is going to be equal to, that's 335.34, and those are square feet. And that looks like that's going to be answer C for question 6. All right, answer C. All right, let's look at 7. Another problem you've seen on your homework assignments the past few nights. Right here, it's a composite figure that we're going to have to split up into 3 figures here. Okay, so let's do that. Area 1 is this little rectangle here. Right, we'll call that area 1. Area 2, now this is the interesting one. Right, area 2 is 2 triangles. Well, when we put 2 triangles together, you're going to see something very interesting when we put the area of the 2 triangles together. And then we have another rectangle here. All right, we're going to call that area 3. My 2 triangles, we're going to call that area 2. Okay, so let's start with area 1. Area 1 is easy. That's a rectangle. Area 1 is going to be equal to the length times the width. So area 1 is going to be equal to, that's 6 times 11. That's going to be 6 times 11. So area 1 is going to be equal to, that's 66 square meters for area 1. Area 2 I'm going to do in green. That's a little bit more interesting. Area 2. Well, area 2 we have a triangle, and the triangle is 1/2 base times height when we're looking for the area, but we have 2 triangles. Well, when I multiply 2 by 1/2, they divide out, so when we rewrite that formula, area 2 is simply going to be the base times the height, right, which makes it rather easy. So area 2 is going to be equal to, well, what's the base? Well, the base, right, the base has to be this distance here. And how do we find this distance? Well, let's look at this picture a little bit more carefully. From here to here is 41, right? It's 41 from here to here. And I'm given the distance from here to here is 11, right? So that's 11. So this is 41, that's 11. So that means that there's 30 left over to be split in between these two pieces, because 30 plus 11 is 41. So each of these pieces has to be 15. And then just check your math. Is 15 plus 11, which is 26, plus 15, does that equal 41? All right, yes it does. Right, so now we have all the information we need. Right, the base is going to be 15. The height of the triangle is going to be this distance here, which is the 20. So area 2 is going to be equal to 15 times 20. Right, that's going to be 300 square centimeters. Area 3 we'll do in blue. Area 3 is a rectangle, so that's going to be length times width. Area 3 is going to be equal to, what do we have? A length of 11 and a width of 20. So it's going to be 11 times the 20. Area 3 is going to be equal to, what's that? 2 times 11 is 22 and add a 0. So that's 220 square centimeters. Now, because it's a composite figure, we're going to need the total area, right? We're going to have to add all of those pieces together. So the total area is going to be equal to the area 1 that we found, plus the area 2 that we found, plus the area 3 that we found. So that's going to be 66 plus 300 plus 220. And when we add that together, what's that? 500, 520, and 66. 586 squared centimeters. And 586 squared centimeters looks like that's going to be answer A. All right, that's a really solid problem, right? Composite figure made up of 3 different shapes. We find the areas of each individual shapes. We add them together to get the area of the composite figure. Okay, let's look at problem 8. A little bit different problem 8, because problem 8 here, we have we're looking for the area of this part, and let me shade that in. All right, we're looking at this area in here. All right, that's what we're looking at. We're looking at this area. Let's shade that in. All right, we're looking at this area in here. All right, this area. Now the area, this area is actually the area that is inside the square, but outside the semicircle. So how are we going to find just that green area? Well, first we have to find the area of the square, and then we're going to take away the area of the semicircle. Watch. Now watch. Let me just show you what we're talking about here. So I'm going to fill in this whole square. So the first thing we're going to do is find the area of that entire square. So we're going to call this area 1. Area 1 is the area of the entire square. Area 1 is equal to 30 times 30, right? Because it's the area of the entire square. So area 1 is going to be 3 times 3 is 9 with 2 zeros. So that's 900 square feet, right? That's that entire green area that we just found. Area 2, do that in blue, area 2 is going to be the area of the semicircle. So area 2 is going to be equal to pi times the radius squared, but because it's a semicircle, we have to take half of that area. So area 2 is going to be equal to 3.14. Now what's the radius? Well, if this distance here is 30, the radius is half that distance, so the radius is going to be 15 feet. All right, we're going to have to square that, and then we take half of that. So area 2, with your calculator, you have to do the 15 squared first, so that's going to be equal to 3.14. 15 squared is 225, but then we need half of that area, so we have to divide that by 2. All right, so with your calculator, you want to do 3.14 times 225, and then we want to divide that by 2, and we get 450, is that right? Let me do that again. 3.14 times 225. Then I want to divide that by 2. That's right. Yeah, area 2 should be equal to 353.25. Those are square feet. Now, we found area 1 and area 2. Now watch what we have to do. In order to find the area that we initially started with, we have to take away or subtract area 2. Right? We have to take away or subtract area 2. By subtracting area 2, what's going to be left is the shaded areas. So we want to subtract. All right? So the area is going to be equal to area 1 minus area 2, right? It's a little different. So we have to subtract those two numbers. So that's going to be the 900 minus the 353.25. All right, so we do that, minus the 900. We wind up with 546.75, and those are square feet. All right, and that looks like that's going to be answer A here. All right, so for problem 8, we get answer A. All right, couple more problems to do. Problem number 9, a circular clock face has a diameter of 7 inches. Just want to sketch that. All right, something like that, 7 inches. What's the area of the clock face? Round to the nearest tenth. Now the reason why I put something like this on is because we're sometimes so used to doing problems where we see a picture or we see a number. When we have a problem that asks us to read a sentence and interpret it, sometimes that can be a little difficult, but I'd suggest sketching a picture. And once you sketch the picture, it's a pretty easy problem, right? Because we're looking for the area of the clock face. Area is going to be equal to pi times the radius squared. Area is going to be equal to 3.14. Your radius is going to be half of that diameter, so that's going to be 3.5. Right? And we have to square that. So area is going to be equal to 3.14 times 3.5 times 3.5. Let's do that. 3.5 times 3.5. When we square that, that's 12.25. And then we have to multiply that by 3.14. And we wind up with 38.465. Area is going to be equal to 38.465. But then we're asked to round to the nearest tenth. Underline the tenth digit, look one place to the right. That 6 tells me to round that 4 up to a 5. So the area is going to be equal to, that's 38.5. Those are square inches, and that's answer A. All right, so we get answer A. And then question 10. Find the area of a circle with a radius of 73 feet. Once again, similar to problems 1 and 2, but in question form instead of a picture, right? So it shouldn't be that hard, right? We write our formula. Area is going to be equal to pi times the radius squared. Area is going to be equal to 3.14. We're told the radius is 73. We're going to square that. So area is going to be equal to 3.14. Now what's 73 squared? It's going to be a pretty big number. 73 times 73 is 5,329. And then we want to multiply that by 3.14. We wind up with 16,733. So the area is going to be equal to 16,733, right? And 600ths. Those are square feet. And it looks like that's going to be answer B. All right. So your quiz is going to pretty much look like this tomorrow, guys. So do your best with the problems. You're going to have to show your work. You're going to have to submit that work electronically. I want to see pictures of your work, please, in order to get credit. And submit your answers electronically as well through the ExamView app. And hopefully you guys are all doing well. Take care.